Hello friends, I JP Dikshit. Today we introduce about automata. In general, it is known as theory of automata and formal languages. What is automata theory? Theory of computation is based on mathematical computation. These computations are used to represent various mathematical models. In general, it is defined as abstract model of digital computing device. Notice that a device need not even be a physical hardware. Theory of computation, a historical perspective. In 1930 to 1970s, the growth of the automata in the terms of the Turing machines, decidability, solving problems, finite automata. Noam Chomsky proposed the Chomsky hierarchy for the formal languages. In 1969, NP Hall problems. In 1970s, compilers computational complexity theory involved. When we study automata, we also focus on the alphabets, strings, grammar, and languages in depth. The alphabet is set of symbols. Zero and one. The word is represented the sentence or string of the symbols. A language is collection of sentences of finite length of constructed from a finite alphabets of the symbols. Whereas a grammar can be regarded as a device that enumerates the sentence of the language. Notice more, nothing less. Basically, grammar defines the finite list of rules defining a language. Also discuss with the productions. A string or word is a finite sequence of symbols chosen from sigma symbols of the sets. Empty string is epsilon. Length of the string W denoted by mod W is equal to the number of non-epsilon characters in the string. Suppose that, for example, 010100, the length of X is 6. Can you tell about what is the length if we include in epsilon symbols? XY concatenation of the two string X and Y. Now language. Language L is said to be language over alphabets. Sigma only if L is subset of sigma closure. This is because sigma closure is the set of all string of all possible length including 0 over the given alphabet sigma. Let us example. Let L be the language of all string consisting of n and zeros followed by n ones. L is defined as sigma epsilon 01 0011 and so on. Let L be the language of all strings with the equal number of the zeros and ones. That's the number of zeros and 1 are equal, including epsilon. Canonical ordering of the string in the language. Empty denotes the empty language. L is equal to empty set. L is empty. The application of the finite automata. There are some applications existing, such as software for the designing and checking the behavior of the digital circuits, lexical analyzer of the topical compilers, software for the scanning large bodies of the text for the pattern finding, software for the verifying system of all types that have a finite number of the states. It's probably used in communication and network protocol, used in the switching theory, play important role in electronics and communication devices. Now we discuss about the finite automata. In generally, a state diagram that comprehensively capture all possible states and transition that a machine can take while responding to a stream or sequence of input symbol. Recognizer for regular languages defined as DFA and NFA. In DFA, the machine can exist in only one state at any given input and given time. Whereas NFA, the machine can exist in multiple states at the same time for a given input. Transition table, it is dependent upon the transition diagram. Focus that. Q is the set of states, sigma is the set of inputs. Start state represented by arrow. First one, Q0, final state Q2, represented as double circle. Transition table defined as states and input symbols. Suppose that at state Q0, input is 0, then transition is Q1, and Q0 at input 1, transition is Q0. Same, you can create transition table with the help of the transition diagram. So we discuss about the DFA, that is the basic 5 tuples, capital Q, sigma, Q0, F, and del transition state. Finite set of the states, a finite set of the input symbols, a start state, set of the shifting states, a transition function, which is a mapping between productions. What does a DFA do on reading as input strings? A word W in sigma closure. That question arises, is word accepted by DFA? We, with the help of the transition diagram, we can define it. Start the start state Q0 for every input symbol in the sequence W. Compute the next state from the current state given the current input symbol in W and transition function. If after all symbols in W are consumed, the current state is one of the accepting state, then accepted W. Otherwise, W is rejected. That is compulsory to transition state become at the final state. Example. Build a DFA for the following language. Step for building a DFA to recognize the L. Sigma is equal to 0, 1, that is the input. Decide the state Q. Designate start state and final states. Del decide on the transition. Final states represented accepting states. Other states same as the non-accepting states. DFA for the string containing 0, 1, focus. Start state, the transition at 0 and 1. Accepting state 1, 0, 1. That is the diagram for the containing 0, 1. That is compulsory to design a transition table depend upon the input symbol 0 and 1 at the different stages. Extinction of transition to path transition. Path transition flow represent the sequence of states for accepting final state. Language of a DFA accepts string W if there is a path from Q node to accepting or final state that is labeled by W. Language of A equal to word path Q node W belongs to final states. The complete path transition accepts the final states. Language of A, all string that leads to an accepting state from Q node. Now NFA, non-deterministic finite operator, general also known as the NDFA. Of course, non-deterministic implies that machine can exist in more than one state at given time. State input are the same at the different state transition. It also have the 5 tuples Q sigma Q naught F del. Suppose that if we constructing a NFA for 0, 1, kindly focus that at the same input the transition is different states represented in transition diagram and transition table. You can pause the video and understand the process of this. Example, build an NFA for the following languages. L equal to word ends with 0, 1. The keyword recognizer, if then else, file for include, and so on. String where the first symbol is present somewhere later on at least once. Extension of transition to NFA paths. Basically, not accepting the final state is not compulsory. Its path is depend upon the state. Language of NFA. An NFA accepts word W if there exists at least one path from the state to accepting a final state that is labeled by W. What is the difference between NFA and DFA? These are the basic difference between NFA and DFA. In DFA, all transitions are deterministic. Each transition leads to exactly one state. But in NFA, some transition could be non-deterministic. A transition could lead to a subset of state. In DFA, for each state transition on all possible symbols, alphabets should be defined. But in NFA, not all symbol transition need to be defined explicitly. If defined, will go to an error state. This is just a design convenience, not to be confused with non-deterministic. Whereas in DFA, Accept input if the last state visited is in F final state. In NFA, accept input if one of the last state in F. In DFA, sometimes headers do constructs because of the number of the states, whereas in NFA generally easier than a DFA to construct. In DFA, practical implementation is feasible, but in NFA, practical implementation limited but emerging Micron's Automata processors. So these are the basic difference between NFA and DFA. If you want to convert NFA to DFA, that process is very simple. We discuss about these in next video. So please keep in touch. Please suggest the suggestions and like all videos, subscribe my channels and forward to all your friends. Thank you.